Number 46. Find the ratio of the mass of Jupiter to that of Earth, based on the data in table 6.2. All right, so the data here in the table provides information about parents, like parent planets or parent systems, and their satellites. And remember, satellites are just objects that orbit that particular parent system. They give us then the orbital radius, right, in the period, and then the radius cubed divided by the period squared values as well. So what we need to do, realizing, some of the information that's given in this table, and somehow we have to then relate the masses of Jupiter to that of Earth. All right, I'm probably then going to be using this formula down here on the bottom. All right, let me detail what that formula represents. This formula represents the period squared of a certain satellite around its parent is equal to 4 times pi squared multiplied by the radius between that satellite and its parent cubed, all divided by the gravitational constant, multiplied by the mass then of the parent. Okay, so let me just put r sub s here for basically the radius of the satellite. All right, I should be saying between the satellite and its parent. So keeping this formula in mind now, all right, what I'm going to do is I'm going to create two formulas, one that relates the mass of Jupiter to one of its satellites, and then another formula that relates the mass of the Earth to one of its satellites. Okay, so let's do that. Let's create the two equations now. So we have, so first, actually, let me highlight it over here. So let's go to Jupiter. Let's use Europa's data. It really doesn't matter which one you use. You can choose any of the four. All right, I just like the word Europa. So here we have the period now of Europa. I'll put it as little e. Okay, squared should equal then 4 times pi squared. And I forgot the squared up here, guys. You see that? Silly mistake. 4 times pi squared times in the radius of Europa, between Europa and Jupiter, that is, cubed, all divided by the gravitational constant, multiplied by then the mass of Jupiter. Okay, so that takes care of that one. Let's now look at Earth and its satellite. So I'm going to highlight this column up here. All right, and its satellite is the moon, right? That's the information they give us. So let's do that now. So it says the period then of the moon, all right, squared should be equal to 4 times pi squared multiplied by the radius between the moon and the Earth cubed, all divided by then the gravitational constant multiplied by the mass of the Earth. Now, again, we are trying to find a ratio, go back to the problem. We're trying to find a ratio between the mass of Jupiter and that of Earth. So in thinking about what they really want us to find, they want us to find the mass of Jupiter as it relates to the mass of the Earth. Okay, so this is what I'm looking for. So now realize that, in this formula here, I have the mass of Jupiter. And in this formula down here, I have the mass of the Earth. So what do you think the strategy is going to be here? The strategy is going to be to solve, there's a couple of ways to do the algebra, but the strategy basically is solve this equation for the mass of Jupiter, solve this equation for the mass of the Earth, put then the mass of Jupiter over the mass of the Earth, as we see over here, and then just plug in the numbers. All right, so that's what I'm going to do. So let's solve this system right here for the mass of Jupiter. Now realize it's in the denominator. I want it in the numerator and by itself. So basically I'm just going to take it from the denominator here, bring it up to the numerator on the left-hand side, then bring this numerator value, right, it's really over 1. So bring this numerator value on the left-hand side down into the denominator. All right, and that's the simple algebra there. So we should now have the mass of Jupiter being equal to 4 pi squared times the radius of Europa cubed, all divided by the gravitational constant multiplied by the period of Europa squared. Okay, and then I would do the same math here, right? So I'm basically just going to copy. It's the same thing, just now with the mass of the Earth. And you know what? I should do this. Let me put E here as capital E so we don't confuse that with Europa. All right, so the mass here of the Earth will be equal to 4 pi squared times the radius of between the Earth and the Moon cubed, all divided by the gravitational constant multiplied by now the period of the Moon squared. Okay, so now here we have two formulas. So now again, we just got to place the mass of Jupiter over the mass of the Earth, right? Just like I have detailed here. And And that would be the same thing, right? Putting the mass of Jupiter over the mass of the Earth would be the same thing as putting this over this. So that's what I'm going to do next. Okay, I mean, I basically have it set up already, if you notice. Right, so basically I'm just going to combine this now into one. Actually, you know what? Let me just do this. Let me just draw a little line here. And there, I put them over one another, right? There it is. This is the numerator. Okay, and this is the denominator. Just don't worry about this part. I'm only focusing in on these pieces, okay? So now all I have to do is plug in the values, all right? And we can actually make some simplifications here. So maybe why don't we do a little algebra here. Now remember, some of you might see this right off the bat, how to do the algebra. But whenever you divide, you know, a fraction by a fraction, an easier way might be to think about it as taking the numerator fraction and multiplying it by the reciprocal of the denominator fraction. So I'm going to set that up over here, okay? So it's basically going to be 4 pi squared, radius of Europa cubed, all over g times t e squared, right? The period of Europa. Now that is going to then be multiplied by now the reciprocal of this denominator. So the reciprocal there is going to, you know, just flip the numerator and denominator. Okay, so it becomes now g times the period of the moon squared, all divided by 4 times pi squared, multiplied by the radius of the moon cubed. All right, so notice what's going to happen. The g's go bye-bye, right? And the 4 pi squareds go bye-bye. So what are we left with now? Right, we are left with then RE cubed, right? The radius of Europa cubed over the period of Europa squared times, right? Times the period of the moon squared, all divided by the radius of the moon cubed. Okay, so now I can plug in those values, or, right, I can just look to my table now, but there's an easier way here, all right? Instead of plugging in, you know, I gotta do this, and then take the period, and then plug in all this stuff and cube it. Look what they do over here on the right-hand side, right? They give us the r cubed per t squared value. So I'm just gonna plug them in. So remember, this is the r cubed per t squared value of Europa. Okay, so here's that value. 3.20 times 10 to the 21. So I'm going to plug that in. So this is 3.20 times 10 to the 21. Okay, now that's going to then be multiplied by this value, right? Which is t squared over r cubed. Now don't get too confused by this. What do they give us in the table here? They give us r cubed over t squared, right? But I need the opposite of that. I need the reciprocal, right? So just realize that this value here, 1 times 1.01 times 10 to the 19, is really over 1, right? And that represents r cubed over t squared. But I need t squared over r cubed. I just need to flip this, right? So really this thing becomes 1 over 1.01 times 10 to the 19th. And now you can see how to calculate this, right? Now this should be fairly easy. All right, so simply just plug this into the calculator. So we get 3.2 times 10 to the 21, all right, divided by essentially, right, 1.01 times 10 to the 19th. And look at that, we get about 317, right? So we get about 317. And that's the answer. That is the ratio. Okay, if I go back up to here, this ratio equals 317 to 1, meaning that the mass of Jupiter is 317 times greater than the mass of the Earth. Guys, thanks so much for tuning in. Please remember to subscribe, and I look forward to helping you with the next question. Take care.